discriminant. And you've either copied the problem down wrong or you've typed it in wrong. So most likely, bottom line is, even if you copied it down wrong, you typed it in wrong. So make sure that you type it in correctly. You will get nice, rational answers. And then we call this factoring over the integers, because every number we see is an integer. 7 and 6, we don't put negative 6/7 up there. We don't put, well, here it's pretty easy on that one. But you only see integers, and that's what we call that factoring over the integers. Every number is not a square root and is not imaginary. Everything is nice or eyes or imaginary, eyes or irrational. So this one would give me, Miss Hallie, there you are. What's the factor to this one?
Positive 3. Or it'd be
2
plus 3. Yeah.
V
plus 3.
Plus 3. And this one, go ahead and give me the second one.
V plus 9.
Okay. And you can always, and the full length is going to have a little bit to do with it in just a second. The 2V times the V is the 2V squared. I really don't have to worry about O and I, because if I check the L and the F, because 3 times 9 is 27. So, you've got it. That's it. GCF is 1. Let's do one more of these, and then we'll go to page 87. And even though we've got plenty of room, I'm going to do GCF on that page so that you see the difference. If you come to me and say, what did I do wrong? I can say, remember, on 87, we did the GCFs other than 1. So let's do 9n squared minus 18n minus 7. Now, by the way, these numbers underneath are not part of your answer. And I don't expect you to put it on your paper. That's your choice. This is just scratch work, to help us get these. Those were the solutions if it had been an equation. Now, when we get into the big polynomials like this, when we start graphing them, you actually you'll want to know what these numbers are, but you'll also want to know what the factors are. So, because those numbers are the intercepts of your graph. This is where that graph crosses the x-axis, if you make it a f of x equals. Okay, I think on this one, is it 7/3 and negative 1/3?
Yes, ma'am.
Okay.
Mm-hmm.
So, Sarah Margaret, what's my two factors going to be?
3 minus 7 and 3 plus 1.
Okay. We like it. It's nice. It's not something you want to depend on all the time. Like x squared minus 6x minus 7. I can factor that faster. But if it will help you, you can take advantage of it, and it will help. Let's go to page 87. And we're going to write up here at the top of the page, GCF, and I guess I should say GCF other than 1. And that's not focused, so let's see if we can get it focused. And we're going to do number 3. So I've got 4r squared minus 10r minus 50 equals, and I'll go ahead and leave a little bit of room out there, because you can always kind of figure something's fixing to happen. But let's talk about why it happens. So I think you get, if it saves you some time, I got 5 and negative 5/2. If you don't get that, let me know. Okay. Okay. Kyle, can you give me the two factors? We're doing with r's. And remember, the order doesn't matter. Multiplication is commutative, so you can put either factor at the front.
2r plus minus 5.
Okay, now wait a minute. You're doing this one first? Okay. So you said 2r minus 5?
Is there
Okay, let's go back over here.
Wait, I'm saying, do you see, is there a negative on that?
Okay, now wait a minute. Yes, can you not see that negative?
Let's see.
Okay, I'm sorry. Can you not see that?
It is my fault.
Okay, let me see if I can brighten it up just a little bit.
2r plus 5.
Okay, there it is. It's kind of a little blob now. So you got 2r plus 5. And this one?
R minus 5.
Thank you. Now, if I fold this one out, and I want you to write this on your paper, we get 2r squared. I'm going to do the O and the I together. I've got negative 10r, and I've got positive 5r, which is negative 5r, and then I've got minus 25. Now, I think all of you would agree that those are absolutely not the same problems. If I make them f of x, they're not the same graphs, and that's where I'm really going to address how you know what's going on. Why do they have the same answers? Because if you type this in the quadratic formula, you get this. And if you type this in the quadratic formula, you get this. And there are infinite ones that will have those answers. And the whole effect of that is coming from right here. Because as that number changes, if that number is a 1, it's this one. If that number is, well, what's going to make it this one?
2.
2.
A 2. Because you're going to distribute a 2 all the way across, and it will give you this one. I told him last block, if this was a -3, it will still have those solutions. But especially the graph makes a big difference. Let me show you. Now, I did something extra, so let me erase one of these. Okay, so what I did was this one. I may have it upside down. Oh, I bet I erased the wrong one. Okay. I just estimated, kind of pretended that, because I know this one has a y-intercept of -50 if I make them functions, and this one has, and this is probably the best way to see it, and this one has a y-intercept of -25. So I kind of sketched them. Now look what's happening. This one has an A of 4, and this one has an A of 2. So they both open up. The up 2 over 1 is going to be, it's going to be fatter than the up 4 over 1. And so I kind of just gave you an idea. So this would be like -50. This would be like -25. And they cross the x-axis at the very same places. And I said, what if I made that problem, same solution, same x-intercepts, but I put them in -3 there? I said, then it would look something like this. See, something on that order. So you have to recognize there are infinite quadratics that have these two solutions. There are infinite parabolas that have those two x-intercepts. But there's only one, in this case, that particularly has a 4 here. So you just have to watch what you're missing here. Now, when do you know? I can red flag that and know there was a GCF. Most of you can. Most of my college, I don't know why I want to say that. Most of my regular Algebra 2 don't recognize GCFs. They would have started factoring 4 and 1 and, 50 and, or 25 and 2 or 50 and 1. And then that's where it just gets a little messy and you have to take GCF out. But this will tell you that it did have a GCF. If you took the 2 out, it would look like that. And then you factor from there. Number 4. 40x squared. So you're just watching. Does this have a GCF? And really, you only have to check the F. Now, I love factoring, and I love a challenge. But especially as busy as my days are, I stayed till 5 yesterday afternoon. But I got all slips done. I got them all graded, and I got all in the computer. And I think I can do better today. Ebony got second block's quiz already graded. Can probably do yours. I think you get 5 fourths and -9 halves.
Mm-hmm.
Okay. And Evie's going to give me those two factors.
Oh no. You get 4x minus 5
And?
and 2x plus 9.
Okay. And I mean, there's the -45 on the end. There's an 8x squared. But that's the really red flag right there that tells me, because you've got your O and your I and your L out here. But it tells me that even though these two have the same solutions, this one actually has a GCF of, well, what are you watching for? You want to know what times 8x squared will give you 40x squared, 5. Because see, if you go back to these, let me flip back over here just a second. See, if I fool that, 7m times m is 7m squared, and there it is. So we know there's a 1 in front of it, because 1 times 7m squared is 7m squared. So that kind of leads you back to why the GCF was 1 here. And I can look at that and know that all of them were divisible by 5. Now, that might not have been the biggest one, but it is a factor that would go into it. And 5, this is one a lot of people miss when they get a common factor out, but they don't get the biggest one out. 24n squared plus 96n minus 54. Okay, you can check your solution, see if you got the same thing I did. And the writer's going to give me the factors. Did you get the same solutions, writer? Okay, what's the factors? You need to put your mask up over your face for me, writer. I mean, you may be social distance. I guess you probably are, so you're okay. This is the only group that I can probably social distance on.
2n minus 1 times 2n plus 9.
Okay, that looks good. 2n times 2n is 4n squared. So what is the difference in these two? What do I need to put out here?
6.
And see, a lot of people would have looked at that back when we were doing them with GCFs, when we were solving, factoring quadratic equations that had GCFs in them. You would, might have taken a 2 out, might have taken a 3 out. I don't know that you would have recognized that 6 would go into all of them. But pull that out and you'll get that answer. So it's a nice little feature. And we actually used it yesterday in regular Algebra 2 to do something with these big old polynomials, to factor them and to solve them. And then and they're probably not going to do graphs with them, but that'll also help you with the graphing. We good to go? Think you got it? Man, I did good, Sarah Margaret, because they had 10 this morning, and y'all have got 20. But I went on and gave you those solutions, so all of that helped. So let me turn this off, and let me go over here, and let's hope this worked good.